Hello, I'm Biritesh Kumar and I'm here to explain you about Jominey End Quench Test. Before going to that, why do we do this Jominey End Quench Test? We do this test in order to know the hardness of a material. This hardness is not only a hardness which depends upon the material and directly extracted from its ore. We call this hardness and we test it because of the way which we treat the metal or an element when it is heated, and depending upon the way which we cool, we know the hardness of a material. This hardness can be determined by three kinds of machines. These are known as Brinell hardness machine or tester, hardness tester, Vickers hardness tester, and Rockwell's hardness tester. These are the three different kind of machines which we can determine the hardness of a specimen or a material. So before going to that, I would like to tell you what is actually hardness. Hardness is nothing but the resistance offered by a material in order to prevent the formation of indent, or in order to prevent a fatigue which happens on the surface of a material. This is known as hardness. So this hardness can be increased by different treatment of cooling methods for a specimen. For a specimen or a metal, when we cool it suddenly, or when we cool it by giving it time, or when we cool it slowly, depending upon these three factors, the hardness of a material varies. The hardness of a material generally varies by three kind of process: quenching, annealing, and normalizing. So first we'll come to quenching. Quenching is nothing but heating an element to more than austenite temperature, which means more than 700 or 900 degrees Celsius, and then cooling it suddenly in water or oil so that it forms a very tiny green particles, so that the attraction between each and every particle is very strong when compared to other two methods, while increasing the hardness of a material. So normalizing is nothing but cooling the material after heating it to austenite temperature or martensite temperature, not martensite temperature but a little more than martensite temperature, and then cooling it slowly with the help of putting it in the air. For example, when you take a specimen out of the furnace and put it in the open air, it cools at a rate depending upon the air temperature or atmospheric temperature which is present outside. So depending upon that, the hardness of the material differs. So in this normalizing, it is given a time, some time, in order to form a grain kind of structure, and then it forms a complete grain, a solid grain, which has relatively less amount of attraction between each grain. More the grains present, more the attraction will be there. So more the attraction, more the hardness of the material. So here I come by Jominey End Quench Test. Here we use few specimens and some kinds of apparatus which we have the measurements fixed. So a specimen, for example, you can take a specimen of length 100 mm and thickness of, the dia, actually it is taken as a cylinder rod. So the dia of the specimen is nothing but 25 mm, and the length of it is of 100 mm. So we put a pipe kind of thing which projects water onto the specimen in the upward direction so that it reaches the specimen and cools it down, which is also called as quenching. So before we go to that, the dimensions of the pipe should be, these are the minimum requirements for uh, Germany and Quench test, because depending upon these things, these kind of requirements, we change the formation of a grain. The time given means, because the distance between the specimen and the pipe should be of half inch, because these kind of rules help us to understand how a material is getting quenched. Depending on these conditions, the material gets quenched or normalized. These are the main factors, and on these we can determine the hardness of a material at different stages at different times. So the specimen is being heated in austenite temperatures in the furnace and taken out. It is put on a experimental setup, and then from the bottom, from the half-inch gap, a water flushes out. I mean, it's just like a rushes out, like a fountain thing. So it just hits the specimen directly at the bottom. So while hitting the specimen directly at the bottom, what happens is that the bottom end quenches, because the water is normal at a temperature or cooled, and then due to the sudden cooling of the specimen because of the water, it quenches. So that as specimen is being conducted, I mean conduction is normal because of the laws of thermodynamics. So because of the conduction, the coolness is being the hotness from the top end is being transferred to the bottom. So this process is after up to 20 minutes, depending upon the time which you take and the quenching medium whatever you take. It is being limited to 20 minutes because the specimen, after heating to austenite temperatures, what happens is that the temperature, if it is being heated more than 20 minutes, let's say that it's heated to 30, it's cooled for 30 minutes, the whole heat in the specimen is being disappeared, and this one is being put into the specimen, in the experimental setup, and then it is cooled. And in order to check its hardness, we use a Rockwell hardness tester. We can test, I mean we can notice all the hardness values at a specific point, taking from the bottom end 10 mm per 10 mm per mark. From these marks we will be knowing the hardness of the material. So from the bottom it has got quenched, and at the top it has got normalized when we compare. So this one is being normalized, and while it is being increasing its distance from the bottom, the hardness value decreases, because at the quenched end it forms a very low grain, irregular grain structure, and because of it the hardness of the material will be very high. So hardness from the bottom will be top, and at the end will be low. Depending on this factor, each distance covered from the bottom to the top, we take a certain graph which we get as a curve. For example, a half of a parabolic curve, more than a half, but we consider it as a parabolic curve. So these are the main requirements for a Jominey End Quench test. This is the most simplest when compared to other hardness testing machines, hardness testing methods, not machines, methods. So depending on this we can know the hardness of the machine. Thank you.